Here we're going to look at example 3, where we rewrite the product or quotient of a radical. So in part A, what is the fifth root of 16 times the fifth root of 8 in reduced radical form? So let's just rewrite these. What's going on here is we have an index of 5 and an index of 5. So what that tells me is that we are allowed to combine these pretty easily, and all we need to do is take the fifth root of 16 times 8. So, and this is very important, since the index of 5 is the same, or it's an index of 5 for both of them, we're allowed to put them back together. If you had something like, let's say the square root and the cube root of 5 in this case, you can't just merge those this easily. You can put these together, you are able to multiply them, and we'll see that in part B, but it's important to note you need to look at the index, and if the index is the same for each, then it's a little bit easier. So we can move forward with that. 16 times 8 is 132. Sorry, that's not true. 128. And then what we need to look for is, are there any perfect fifth roots that go into 128? So what that means is 1 to the fifth would be 1, 2 to the fifth is 32, 3 to the fifth is something larger than 128. So 2 to the fifth, 32 does actually go into 128. So this is going to be the fifth root of 32 times 4. And then we can take the fifth root of 32, which would be 2. That comes out. And then we'd have the fifth root of 4. And this would be our reduced radical form. So once again, like I mentioned at the start of this problem, what you have is an index of 5 for both terms. You're able to merge those together very easily. Now in part B, what I have here is I have the sixth root of 8x times the third root of 2x. Now in this case, obviously my index of 6 is not the same as my index of 3. So if I want to combine these, what I need to do is I need to rewrite them using rational exponents first. So that means this 8x would be raised to the 1/6 power, and the 2x would be raised to the 1/3 power. And now using my properties of exponents, since I'm multiplying the bases, what I am allowed to do is I can kind of manipulate my exponents a bit. And I can change this to be 8x to the 1/6 times 2x to the 2/6. Moving forward, again, more manipulation here. I can then take this as 8x to the 1/6 times 2x squared, and that raised to the 1/6 power. Sorry, that's not a 6. To the 1/6 power. Right, looking at these, this 2 times 1/6 will get me back to this 2/6 where I was. So I'm just using properties and I'm kind of manipulating this in a way that would help me out. Now what we see is that both of these bases here are being raised to the 1/6 power. So I can change this, let's write this up here, to be 8x times 2x squared, and the entire expression raised to the 1/6 power. These are a lot of rules that most problems won't be as complicated as this one, but these are some rules that you'll be able to apply, and as you get better at these, it's not a guess and check thing. You'll start to understand which properties you should be using more frequently. So don't stress yourself out. Don't overwhelm yourself with this just yet. There is a lot going on here. There's a lot of, like I said, manipulation of the numbers and the form that they're written in. And as you get more exposed to these and you get better just doing them more frequently, you'll start to look for specific types of things. All right, so I'll stop talking about that and actually do the problem. This would be 8x, and then this 2x squared I'm going to write as 4x squared. Right, I'm going to take that 2 and kind of distribute it in, and all of this is still raised to the 1/6 power. So I then can keep combining things. 8 times 4 is 32. X times x squared would be x cubed, and all of this is raised to the 1/6 power. Now we're writing a reduced radical form, so I can put this back as a sixth root and write this as 32x cubed. And luckily for us, there are no 6 roots that go into 32, so we can finally stop there. Not the easiest problem. Most people, students, teachers, anyone, not particularly big fans of these type of problems because it does take some manipulation and changing things and making sure that they work out kind of nicely. So understand the process. Again, like I said, don't overwhelm yourself, don't stress yourself out. Try to just slowly introduce yourself to these type of problems. Try to find some easier ones, pick out the easier ones, and you'll start to learn what type of properties you should be using and when you should be using those. As for part C, we'll get to part C in another video. I'm going to combine that with example 6 later in this section because both of them have to do with rationalizing denominators, and I want to show those together.